Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's part 4 about this motion of the constant speed and constant acceleration and then constant deceleration, the bicycle and the car, and we discuss different variations. Today they ask us to build the graph of distance. So let's start as previously. Let's draw the graph of v because we know how it looks. V over t. There is a car that travels. The car that travels with v0. At the moment t is when the car, this is bicycle. The bicycle and the car is accelerating, and this is the moment when the whole car and the bicycle located at the same speed. So this is a graph of the bicycle, this is a graph of accelerating car. At that point it's 2v0, then the car starts to decelerate and build this symmetrical picture, and this is 2t, and when also at that moment, which is 2 half, and this is another 2 half, so it's 1.5t. The speed of both objects are the same, and we know that this formula would be x equal vt at any moment, and at that moment this graph x equal 4v0 minus 80, and so if we would extend this graph up to here, this would be 4v0. But we're not extending, we're concerned only with the real motion, like that. And now they want us to build the graph of distance. And distance is x. And what will happen is that this is the moment t, and this is another moment 2t. So one under another, and we know that x for the car moving, for the bicycle moving with the same speed would be a straight line. And we also know that parabola is the graph for the car that's accelerating, and we know so at that point of time they incline with the same angle because their speeds are the same, and this is tangent of the slope that defines the speed, the velocity. Then at that moment the car starts to decelerate. So if the car starts decelerate, the graph becomes, the formula would be x sum x0 plus sum v0. We took this v0, so I don't know, v initial and x0, let's not to mix it. It would be x0 plus vi t and minus at squared. So we don't know what xi and vi are, but we know that the graph would be a parabola, and we know that the speed will be decreasing, and the car, here they have d, and it will go another d, so this becomes 2d. So it's kind of symmetrical parabola. At the moment 2t, the incline would be 0. The car would be standing still. And so this is the moment then didn't draw a straight line. Let me draw a good straight line to this point. So at that point this incline and this incline would be the same because they will have the same speed. So this is the parabola that truly defined with the formula x equal at squared. and here xi and vi are some parameters. I don't want to tell what those are, but you can plug the number. You can easily determine this if you plug t equal T capital, and instead of xi, initially you can plug this d, and so d would become xi, and you would put this and you will calculate it, and you have to open the brackets, and it would be some numbers. Akin here it would be 4v0, where this graph crosses the horizontal. If you want my hint, it's a little bit offbeat, but this graph of this parabola will go like this. So this would be some negative number, this x initial. And of course it never goes like this, because we're interested only in this period of time, right? But basically I don't want to go there right now. I don't want to overcomplicate things. For now, it's sufficient to say that all that I wanted to prove here is that this is a parabola, this is another parabola, branches here are up, branches here of this parabola, if we will continue, are down, and this is because we're decelerating, and the fact that we're decelerating means that in all our formulas a should be negative, but this also shows you how those two graphs are related to each other. So I hope that was clear and this was useful. So please subscribe, bell, like, comment, question. I gladly answer your problems. Thank you.